Let us talk about SVM support vector machine today. This is developed by Dr. Vapnik based on his theory developed in the 60s. It was not popular then until he proposed SVM. It used the boundary concept, and we want to discuss about that in this class. It tried to maximize the margin, and surprisingly, it performs super well in many different places. So SVM has been used in many different areas, such as handwriting, digital recognition, object recognition, speaker identification, benchmark time series, bioinformatics, even bioinformatics, the research that I'm doing now. So it's actually very useful, and it can be used in classification as well as prediction. What it tries to do is that in the regular linear classification problem, you try to draw a line to separate two classes if that is a by-class problem. And the data below the red line indicating one class on the other side is another class. So this SVM probabilistic classifier all use this type of theory to make the prediction. What makes SVM very special is that it is used for linear as well as nonlinear data. It uses a nonlinear mapping to transform the original training data into a higher dimension when it is not possible. With the new dimension, it searches for linear optimal separating hyperplane, which they try to increase the boundary of the hyperplane. And that sounds crazy, because what I try to do is that if the two dimension, for example, is not able to separate the data, it will create one additional dimension and then try to separate the data. If three dimensions still not working, it will go into a higher dimension. So the theory in back of it is very deep, and of course it's not very easy to program. SVM support vector machines with an appropriate nonlinear mapping to a sufficient high dimension. Data from two classes can always be separated, and the SVM find this hyperplane using support vectors and margins try to make the decisions. So let's take a look at this example. Of course, this is in a pretty straightforward two-dimensional data. It has two classes. Whatever line that you try to draw can successfully separate the two classes. So what is the theory in back of SVM? What SVM trying to do is that there are many lines can be drawn. However, it likes the one that can give you the maximum margin. So you can see that on this line, it has the margin like this way. However, the other line can have actually a bigger margin. So this one is better than the other one. For the lines that you draw that gives you the maximum margin, they are going to have some points or some classes lying on the border. And these are what we call the support vectors. As you can see, we get the maximum margin, and now in this case, we have three support vectors. And support vector machines use those support vectors to make the judgment. The complexity of training classifier is characterized by the number of support vectors. So it's actually those are the key components to make the decisions. The support vectors are essential or critical training examples. If all other training examples are removed from the training is repeated, the same separating hyperplane would be found, which means that support vector machines use only support vectors to make the decisions. So you can see that the idea of using the support vector machines is actually very interesting. In this case, the figures shows over here is saying that when there is a linear line that are not able to find the results, it is also possible to make it a nonlinear line, which means that we can also, in SVM, we can also use nonlinear surfaces to create the maximum margin as well as generating those support vectors. So SVM has a lot of advantages. Its prediction accuracy is usually very high. It's robust. It's fast evaluate of the learn target functions. There are some problems. First of all, it requires some time to do the training. And most important problem in SVM is that it is a black box classification, which means that you have no way to understand the learned function, and it is hard to retrieve the knowledge from it. That's why it usually gives you a very high accuracy, but the information that you want to retrieve may not be possible. So this is a very brief introduction about SVM. And there are actually many packages that are possible to run SVM. The main purpose of this class is not ask you to program SVM, which is not very likely. The major purpose of this class is I want you guys to have experience running SVM. So SVM has several famous packages that you can use: libsvm, SVM Lite, and SVM Torch. The one I am going to give you guys in this class is SVM Lite. So SVM Lite can be downloaded from this web link. It is developed by Cornell University, United States. Once download, you can get several files that you will be able to get. So basically, what you will be able to get is that you will get the two important programs that are executables. So what I have done is that I already downloaded and I have that been available in my computer. So I create a C folder named SVM, as you can see over here. The two files I put into the class folders are SVM classify as well as SVM learn. So those two files give you the functionality of, first of all, building up. SVM learn give you the capability of building up a model. SVM classify is basically use the model you built and make the prediction. So let's take a look at this. First of all, you need to use SVM learn to train the model. So you need to use SVM learn as the keyword and then to provide the file name and then give the name that your model is going to be. So once you have done that, you get a model, then you can run SVM classify on the testing file that you want to test based on the model you created from SVM learn and then generate an output file. That sounds like pretty complicated, but let me show you how does that going to work step by step. And in the same files that I gave you through the Blackboard, you will be able to see that I give you two files. One is testing file, the other one is training file. You may notice one thing: if we open up the testing file, which is a smaller file, it looks kind of scary, but it's not as bad as it looks like. What you can see is that for each line, for one data, so this is actually one data. One data, this is of course Y data. The first negative one indicating the class, indicating this is a 90 minus 1, and then they are having the attribute values. So this is the format that SVM Lite would take. You need to give it the attribute number, and then give it the value, attribute number, value, attribute number, and value. So you can see that this is actually 1Y, 90 minus 1 with all the values corresponding to its attributes. And there's another one, another one, another one. So you can see based on this format, this is what SVM Lite would take. What you are going to do is that you go into the CMD command line so that we are able to execute the code. So if you type in CMD, you will go into the command prompt, and then when you are going to do cd/ indicating you want to go back to the C drive and then change to SVM, because the folder that I store all of this information is under SVM. As you can see, SVM over here. So now what I can do is that I can start doing the SVM learn, and then I'm going to provide the file that I want it to train. So I'm going to do the first train, which has a bigger file. I encourage you guys to take a look of the file and try to understand what it looks like inside of it. So I provide the file I want to do the training, and then I'm going to create the model, say model, say 3, 1. So when I hit enter, you will see the program is running and then trying to get the information out of it.